Okay, so here's a problem from an exam from a couple of years ago. Looks like it was from the fall of 2014. Anyway, there's a set of numbers here, and I will present them like this on an exam where there are 4 columns of numbers and they're in order. And anyway, we want to compute the 5-number summary and then draw a box plot for those numbers. So the 5-number summary is just when you have a list of numbers in order, an ordered array. It will be the minimum value, the first quartile, the median value, the third quartile, and the maximum. Of course, the minimum and maximum will be 8 and 75. To get the first quartile, there's actually more than one formula that you can use for this. The one that we'll use, just to keep it simple, is if I have 25% of the values are over here, between 8 and 28, then 3/4 from 32 up, we'll just get this right here will be our 25% of the numbers. So we'll go between 28 and 32, just go halfway between. That'll give us a first quartile of 30. Similarly, for the median, we'll go halfway between 35 and 36 to get 35.5. And for the third quartile, we'll go halfway between 39 and 41 to get the third quartile. So I'm just going to go ahead and write these in over here. And so there's your 5-number summary. Again, just going back to the Q1 of 30, I just took the 28 and the 32 and just split the difference between those to get the 30. And then the same thing for the next things. That you can only do that if you have it like I have here, 4 sets of a number divided up into 4 equal size intervals of quartiles where I have just the 4 columns there. If it gets any more complicated than that, you just use a calculator or a computer to get the 5-number summary. Okay, so to draw the box plot, if we just do a simple box plot, and we'll go a little bit further than that in a moment, but for a simple box plot, you just draw a box that goes from Q1, which is 30. I'm going to draw this on the bottom here, to Q3, which is 40. I'm going to save the top for when I make this a little more complicated. But so that goes from Q1 to Q3. And then we're going to drop a line in the middle for the median. There's 35.5. That's the median. And for a simple box plot, we will extend whiskers. You've probably heard this called a box and whisker plot before. Up to the maximum value and down to the minimum value. Well, when it says here on Part B to include outliers and extreme values, and then show how we're going to get those values, we're going to have to make some calculations here. An extreme value is any value that's more than 3 IQRs from the box. Now, an IQR is just the width of the box here, or Q3 minus Q1, which is just 40 minus 30 is 10. I have a space here, so I'm just going to write the 10 there. So that is the interquartile range, or IQR. So what we're going to do is we're going to go, to get an extreme value, we're going to go 3 of those interquartile ranges. So an interquartile range will be about 15. That's just the width of the box plus 0.5. So we'll go 1 of those, 2 of those, 3 of those. And I don't know if I've got it to scale here, but anything that would be more than 3 of those box widths, or interquartile ranges above or below the box would be an extreme value. For an outlier, it would be 1.5 IQRs on either side. So let's do the calculations here. I'll put those over here. So here is the interquartile range. Looks like I didn't get the I in there. Q3 minus Q1, 40 minus 30 is equal to 10. And then to get the extreme values, put this all over here at once, and then we'll go through it. We'll take, for the upper, we'll go the top of the box, Q3. Remember, it's 3 IQRs from the box, so we'll start at the top of the box, Q3. That's 40, plus 3 interquartile ranges, and that gives us 70. So any value that's above 70, we will define as an extreme value. And then on the lower side, we start at Q1, but we're going down, so it's from the box. Q1 minus 3 IQRs should be 30 minus 3 times 10 is 0. So any number that would be below 0 would be an extreme value on the lower side. So we don't have any extreme values, anything less than 0, so no extreme values on the lower, but we do have a value. This value of 75, I'm going to go up here and just put an asterisk right there. That's how we will designate an extreme value, is by putting an asterisk there. And so we do have one extreme value in the data set. So I'm going to go ahead also and compute the fences. That's just the cutoffs for the outliers. An outlier is any point that's 1.5 interquartile ranges above or below the box. Let's see here, I have right here. So on the upper side, we'll start at the upper side of the box, Q3, that's 40, plus 1.5 interquartile ranges to get us at 55. So now we do have some outliers on the upper side, and I'm going to designate those with a 0 or an O. So there's one there, and then here's another one. So I'm just marking that on here. I'm doing this just to make it easier when I get to draw the actual box. And then this 50, and I'm going to do something here. I'm going to just color that red for here. That's going to be called the adjacent value. It's the last value on this side that's neither an outlier nor an extreme value. It's not bigger than 55. On the lower side, we had Q1, that's 30, minus 1.5 IQRs. So we end up with 15. So we have one outlier on the lower side. I'm going to mark that. So now to draw this, the box is actually going to be the same. The box is just always going to be from Q1 to Q3. And the median is going to be the same. That's that 45.5. So now what I'm going to do is I'm going to, on the lower side, there's one outlier. That's at 8. And then the last value, should have highlighted that here, that's neither an outlier nor an extreme value, is 19. So that means I'm going to extend the whisker down to 19, down to that adjacent value, the last value that's neither an outlier nor an extreme value. On the upper side, I had an extreme value. We'll designate those with asterisks. It's not a great asterisk, but you get the point. It's at 75. That's an extreme value. And then I have an outlier at 61 and an outlier at 58 and an adjacent value of 50. Okay? And so this is a box plot with outliers and extreme values. So here I've just reproduced the box plot and put in some and labeled it so you can see everything on a box plot that was produced using R. And so you can see the box, it's going to be, the default is for vertical. You can change it to horizontal if you want. But the box goes from Q1, that's 30, to Q3, that's 40. The width of that box, 40 minus 30 is 10. That's the interquartile range. And there is the median of 35.5. And then you can see I had, I went ahead and drew in little markers here that were 1.5 IQRs below the box. So that would be the bottom of the box, 30, minus 1.5 IQRs, or minus 15. So there's a line at 15. And then also with a lower fence at 3 interquartiles below the range. We calculated that over here to be 0. So anything in that, within there will be an outlier. If we had anything below that, it would be an extreme value. We don't have that on the lower side. And on the upper side, here's 1.5 above the box. That was 55. And then 3 above the box, that was 70. We had two values inside that those bounds. Those are outliers. We had one value that was above 70, the cutoff for extreme values. That's 75, and that's our maximum value, and which is also an extreme value. So anyway, there that is, and you can hopefully that'll help you out.